In this video, we're going to look at fzero again, but with a different input overloading. Okay, so in the last video we looked at fzero where we passed in a function handle and a guess at what the root might be, a scalar guess. Now we're going to look at using fzero where we pass in a function handle and then a vector with a minimum value and a maximum value that define an interval in which you want MATLAB to search for the root. Okay, so again, fzero is going to try to find a zero or root of the function represented by function handle in the interval defined by min val and max val, which are passed to the fzero function as a vector, as you can see here. Alright, so we call fzero, we pass it the function handle, and then we pass it a vector with min val and max val that defines an interval in which MATLAB should search for the zero or root. Now, it's important to note that min val and max val, when they're evaluated, when the function is evaluated at min val and max val, the answer that you get, the y value in our case, has to have a different sign at min val than it has at max val. And we'll play around with that in a minute. Okay, so we are going to create our anonymous function again. So let me come up here and grab this code. So we will clear CLC, close all. We'll create our anonymous function handle and plot it for good measure. Actually, we're going to have to look at the plot to pick good values of min val and max val. Okay, so let's go ahead and run this section. There's our plot. Okay, right here is one of the roots. Okay, so it's at x equals -1. And we need to pick an interval over which MATLAB should search for that root. So let's try -2 to 0, okay? And to convince ourselves, if the plot isn't enough, to convince ourselves that those are going to be good choices for min val and max val, let's actually say min val is equal to -2 and max val is equal to 0, and then we can pass those values to our anonymous function. So I'll call the anonymous function using the handle, so a non-fun handle, and I can pass in min val. Okay, and that evaluates to +4. And then if I do a non-fun handle and pass it max val, that's -2, okay? So the sign differs. One is +4 and one is -2, alright? So that means that I have chosen good values for min val, or okay, acceptable values for min val and max val. Okay, so let's go ahead and try that in our script here. So I will say root 1 is equal to fzero. I'm going to pass it a non-fun handle, and then my second input is going to be a vector with my min val and my max val. So let's just go ahead and type those in directly. So let's do -2 for the min val and 0 for the max val. Okay, and so if I run that section, I get that root 1 is equal to -1. Okay, let's get that plot back again so we can check out the other root. So the other root is right here at x equals 2. So perhaps a min val of 1 and a max val of 3 would be good choices. So again, let's set min val is equal to, what did I say, 1, and max val is equal to 3, and then call our anonymous function just to be sure. So anon fun handle min val, okay, that evaluates to -2, and then anon fun handle max val +4. Okay, so the sign is different when the function is evaluated at min val than it is when evaluated at max val, so those should be good choices. So let's do root 2 is equal to fzero anon fun handle, and then our min val is 1 and our max val is 3. Okay, and run that. So now root 1, -1, root 2, 2. Okay, and hopefully I've convinced you that which root you get depends on the interval that you pass in. Okay, now let's try to make MATLAB angry. Okay, so let's say root 3 is fzero and then a non-fun handle, and let's give it a min value of -2 and a max value of -1.5, and see what it tells us. Okay, so I did make it angry. Here's the angry red. So error using fzero, the function values at the interval endpoints must differ in sign. Okay, so here's the thing. A non-fun handle evaluated at -2 is 4, and a non-fun handle evaluated at -1.5 is 1.75, both positive, alright, and that doesn't work because the function values at min val and max val have to differ in sign. Okay, so let's just go ahead and comment that line of code out, and maybe put a note here that says bad interval choice, same sign. Alright, now just for fun, let's go ahead and throw those roots onto the plot. So we would need to call hold on, and then we could plot root 1 would be the x value, and 0 is the y value, and let's do red stars, and then plot root 2 for the x value, 0 for the y value, and now maybe we could do a blue star and run that section, and there's our plot with the roots marked with colorful stars.